It's 5:47 a.m. off the coast, and the ocean is glass flat. A fishing boat, engine idling, drifts quietly a few miles out. On the sonar screen, something passes beneath the hull. Not fast, not aggressive, just large. Larger than anything on the operator's chart should be. He checks the reading twice. 52 feet. Longer than the boat itself, moving steadily at depth, then gone. He tells himself it's a glitch. Sonar ghosts happen. He turns the boat toward shore. 2 hours later, a drone filming a surf competition catches 11 seconds of footage that will end up on every news channel on the planet by nightfall. A shadow beneath the waves, wider than a school bus, moving with an unmistakable, ancient rhythm. Marine biologists watching the clip go quiet almost instantly. Because there's really only one animal in Earth's history built at that scale, with that silhouette. Megalodon, the largest predatory shark to ever exist. Officially extinct for roughly 3.5 million years. Except, apparently not. This isn't a documentary about a fossil. This is what happens in the hours, days, and months after the impossible turns out to be true, and the largest predator the ocean has ever produced shows up off a modern coastline. In a world that has spent 3.5 million years assuming it never had to think about this again. Before we go any further, it's worth understanding exactly what just resurfaced. Megalodon lived roughly 23 million to 3.5 million years ago, and by almost every estimate, it was the most powerful marine predator in Earth's history. Size estimates vary, but most serious research puts adult Megalodon somewhere between 15 and 18 meters long, roughly 3 times the length of the largest confirmed great white shark ever recorded. Its bite force is estimated to be the strongest of any animal that has ever lived, powerful enough to crush the skull of a small whale in a single strike. Its diet consisted largely of early whales and other large marine mammals, animals it needed massive amounts of energy to hunt and process. For a long time, popular culture has treated Megalodon as some kind of monster from the deep. In reality, it was simply an extraordinarily efficient predator, occupying the apex position in its ecosystem the same way great white sharks or orcas do today, just operating at a completely different scale. It went extinct for reasons scientists still actively debate. Most likely a combination of cooling ocean temperatures, the decline of its preferred prey species, and increasing competition from a newly emerging predator with a much smaller body but a much bigger brain. The early ancestors of modern orcas. Which raises an obvious question. If it's back, what changed? For this scenario to work, we need one deviation from real history. Somewhere in the vast, largely unexplored depths of the ocean, the hadal zones and deep trenches that make up over 80% of Earth's underwater volume, most of which humanity has still never directly observed. A small, isolated population of Megalodon survives. It's not as far-fetched a premise as it sounds. Deep ocean trenches maintain remarkably stable temperatures and pressure conditions, largely insulated from the surface-level climate shifts that are believed to have driven the species toward extinction in the first place. Several species once presumed extinct for millions of years, the coelacanth being the most famous real-world example, have turned out to be quietly surviving in deep, hard-to-reach waters the entire time, undiscovered simply because nobody was looking in the right place. In this scenario, a small, genetically isolated Megalodon population does exactly that, survives in the deep trenches of the Pacific, feeding on deep-sea prey scientists have barely studied, for over 3 million years, completely unnoticed. Until now, a shift in deep ocean currents, warming trench temperatures, or a disruption to their food source pushes at least one individual up out of the depths and toward the continental shelf, toward the shallower, richer waters where modern whales, seals, and, unfortunately, humans now spend most of their time. So here's the harder question. Even if one surfaced tomorrow, could Megalodon actually survive and thrive in today's ocean? The honest scientific answer is, probably, in the right conditions, for a while, but it would face real competition it never had to deal with before. Food is the first challenge. Modern whale populations, though recovering from historic whaling, are a fraction of what they were during Megalodon's original heyday. An animal that size needs an enormous, consistent calorie intake, which means it would likely need to range across huge stretches of ocean, following whale migration routes, seal colonies, and other large prey wherever it could find enough of it. Temperature is the second issue. Most evidence suggests Megalodon preferred warmer, temperate coastal waters for at least part of its life cycle, particularly for breeding and raising young. That narrows down realistically viable habitat to specific regions, parts of the Pacific, warmer stretches of coastline, areas that already support large modern whale and seal populations. Then there's the competition Megalodon never had to face in its original era, modern orcas. Highly intelligent, fast, and cooperative hunters, orcapods are known to successfully take down great white sharks today by working together and targeting vulnerable areas. A single Megalodon, despite its size advantage, might actually find coordinated orcapods to be a more serious long-term threat than anything humans could realistically throw at it. Back to that morning. Within 6 hours of the drone footage going viral, three things happen almost simultaneously. First, every major news network on the planet drops their regular programming. This isn't a local story. It's the first confirmed sighting of a species presumed extinct for 3.5 million years, filmed in broad daylight, off a beach full of tourists. Within a day, it's the single most watched news event of the decade. Second, coastal authorities move fast. Beaches within a 100-kilometer radius of the sighting close immediately, not out of confirmed danger, but out of an abundance of caution nobody in modern history has ever had to exercise. Coast Guard vessels and marine patrol boats begin systematic sonar sweeps of the coastline, working alongside oceanographic research teams scrambling to get specialized deep-sea tracking equipment into the water as fast as possible. Third, and this is the part that surprises almost no one, public reaction splits almost instantly into two camps. Genuine, understandable fear, especially among coastal communities that make their living on or near the water, and a strange, undeniable wave of fascination, because on some level, a huge number of people have spent their entire lives fascinated by exactly this animal, in movies, in documentaries, in nightmares, and now it's real. Scientists, meanwhile, are having what might be the single most important week of their careers. Within days, this becomes the best-funded, fastest mobilized marine research effort in modern history. Satellite tagging, already a well-established tool for tracking great white sharks and whales, gets adapted almost overnight for a target roughly 3 times the usual size. Specialized dart tags, capable of transmitting location data even from significant depths, become the first priority, because knowing exactly where this animal is at all times is the single most important safety measure available. Acoustic monitoring networks, underwater microphone arrays already used in some regions to track whale populations, get rapidly expanded along the affected coastline, tuned specifically to detect the unique movement signature of an animal this size. Research submersibles and remotely operated underwater vehicles, normally reserved for deep-sea exploration, get redirected toward tracking and observing the animal directly, gathering the first real behavioral data on a living megalodon that science has ever had access to. International cooperation kicks in almost immediately too. Marine biologists, oceanographers, and shark behavior specialists from research institutions worldwide begin coordinating in real time, aware that whatever they learn in these first few weeks will likely define the field for decades. It's a strange, almost contradictory moment. Genuine public fear playing out alongside one of the most exciting scientific opportunities marine biology has ever encountered. While scientists study, coastal communities have to figure out how to live with a genuinely new kind of risk, and the safety infrastructure that emerges looks a lot like an accelerated, supersized version of systems that already exist for regular sharks today. Smart buoy networks, already used in parts of Australia and South Africa to detect tagged great white sharks near popular beaches, get rapidly deployed and upgraded along affected coastlines, sending real-time alerts to lifeguards and beachgoers' phones the moment a tracked signal comes within a certain range. Drone patrols become standard at any beach within the animal's known range, offering aerial visibility that sonar alone can't provide, especially in shallow, wave-churned water where visibility from a boat is limited. Physical barriers, reinforced shark nets, already used at some beaches worldwide, though controversial for their impact on other marine life, gets seriously reconsidered and redesigned, this time engineered with a very different scale of animal in mind. Surfing, diving, and open water swimming communities, understandably some of the most affected groups, develop their own informal networks and apps for real-time sighting reports, not unlike how surfers already track rip currents or shark activity in high-risk regions today. None of this eliminates risk completely, but within a matter of months, coastal life adapts, the same way it always eventually does, cautiously, imperfectly, but functionally. This is the question everyone actually wants answered, so let's address it directly. Based on everything scientists understand about megalodons' likely diet and hunting behavior, humans were never a natural prey item, for the simple reason that humans didn't exist during its original 3.5 million years of existence. Its entire evolutionary strategy was built around hunting large, blubber-rich marine mammals, not the comparatively small, low-calorie profile of a human swimmer. That doesn't mean zero risk. Great white sharks, which also don't typically hunt humans as prey, are still responsible for occasional serious incidents, usually explained by mistaken identity. A surfer silhouetted against the surface resembling a seal, for example. A predator 3 times the size, capable of that same kind of mistaken investigation, represents a fundamentally more dangerous version of an already existing risk, even without any actual predatory intent toward humans specifically. Realistically, the greatest danger probably isn't a targeted attack at all, it's incidental contact. A boat colliding with an animal that size. A diver caught in the wrong place during a feeding event targeting a nearby seal colony. The sheer physical presence of something this large moving through shallow water, regardless of intent. Which is exactly why the safety systems we just covered focus so heavily on tracking and avoidance, rather than confrontation. The goal was never to fight this animal. It was always to simply know exactly where it is. Fear and fascination, it turns out, are both extremely profitable, and within months, an entirely new economy builds up around this animal. Coastal tourism, after the initial shock and beach closures, actually rebounds in a strange, unexpected way. Regulated, heavily monitored viewing tours, boats equipped with the same tracking technology researchers use, keeping a strict, legally mandated distance, become one of the most sought-after, expensive travel experiences on the planet, drawing comparisons to existing great white shark cage diving tourism, just with an entirely different level of demand and price tag. Media and entertainment industries move fast too. Documentary crews, already circling the story from day one, produce some of the most watched non-fiction programming in streaming history within the first year. Merchandising, always a strange but reliable byproduct of any major viral animal story, floods the market almost immediately. The fishing industry faces a more complicated relationship with the story. Commercial fishing routes near confirmed territory require new safety protocols and insurance considerations, while sport fishing and marine tourism operators in the region see a surge of interest from people wanting some connection, however distant and safe, to the biggest story in ocean science in generations. Local coastal economies, initially braced for disaster after the beach closures, end up experiencing one of the strangest tourism booms in modern memory, proof that humanity's oldest instinct, when faced with something both frightening and extraordinary, is very often simply to want a closer look. Fear and fascination, it turns out, are both extremely profitable, and within months, an entirely new economy builds up around this animal. Coastal tourism, after the initial shock and beach closures, actually rebounds in a strange, unexpected way. Regulated, heavily monitored viewing tours, boats equipped with the same tracking technology researchers use, keeping a strict, legally mandated distance, become one of the most sought-after, expensive travel experiences on the planet, drawing comparisons to existing great white shark cage diving tourism, just with an entirely different level of demand and price tag. Media and entertainment industries move fast too. Documentary crews, already circling the story from day one, produce some of the most watched non-fiction programming in streaming history within the first year. Merchandising, always a strange but reliable byproduct of any major viral animal story, floods the market almost immediately. The fishing industry faces a more complicated relationship with the story. Commercial fishing routes near confirmed territory require new safety protocols and insurance considerations, while sport fishing and marine tourism operators in the region see a surge of interest from people wanting some connection, however distant and safe, to the biggest story in ocean science in generations. Local coastal economies, initially braced for disaster after the beach closures, end up experiencing one of the strangest tourism booms in modern memory. Proof that humanity's oldest instinct, when faced with something both frightening and extraordinary, is very often simply to want a closer look. A few months after that first sonar blip, life along the coast finds a strange, new kind of normal. Beaches reopen, tour boats run. Scientists publish the first real papers on living megalodon behavior in human history. Somewhere, quietly, coastal communities adjust the same way they always eventually do, not by eliminating the risk, but by learning to live alongside it. It's easy to frame a story like this as pure horror movie material. But the more interesting version of this thought experiment isn't really about fear at all. It's about what happens when something we'd relegated entirely to the past, something we genuinely believed we understood completely, turns out to still be out there, changing everything we thought we knew. 3.5 million years of assuming it was gone. And it turns out the ocean, which we've explored less than 5% of even now, was simply keeping one very old secret in a part of the world nobody had thought to look. Which raises the real question this story leaves behind. Not, what if Megalodon still lived? But what else, right now, might still be down there?